In this video, we are going to be calculating the upper and lower bounds for different expressions and calculations. A typical exam question might be something like this. We have a rectangle that is 3.1 meters in width and 2 meters in height, and those are both correct to one decimal place. They might ask you to find the upper bound for the area, which I'm going to write as A+. Now, one of the biggest mistakes that students make is they do 3.1 times 2, and then from that they calculate the upper bound being 6.25. That is incorrect. You are missing out on some of the calculations that's a rounding error, and what you have to do is find the upper and lower bounds for each of the measurements and then calculate the area from that. So if I want to find the upper bound of the area, I need to find the upper bound of the width and the upper bound of the height. If you need practice on it, go back, look at my last video on upper and lower bounds. The upper bound of the width is 3.15 and the upper bound of the height is 2.05. Common mistake there is not realizing that actually that measurement is 2.0 because it's correct to one decimal place. From here, to find an upper bound for the area, we would do 3.15 times 2.05, which we put in our calculator to get 6.4575 meters squared. You can then round it if the question needs. That is how you find the upper bound for the area. Let's have a look at the lower bound for the perimeter, because it's effectively the same thing. To find a lower bound of the perimeter, find the lower bound of each of the measures. So the lower bound of the width would be 3.05, and the lower bound of the height would be 1.95. We then just add all four of them up. So we do 3.05 times 2 plus 1.95 times 2. We put that in our calculator, and we get 10 meters. That is an approximation for the lower bound of the perimeter, if our measurements are correct to one decimal place. Now, it can be more tricky when you're dealing with division. Let's take speed equals distance over time. Let's say the distance is 24 meters, and that is correct to the nearest integer. And time is 4.32 seconds, and that is correct to 3 significant figures. If we want to find an upper bound for the speed, another common mistake that students make is they do the upper bound of the distance and divide by the upper bound of the time. But if you think about trying to find the largest speed, you want to cover the greatest possible distance in the shortest amount of time. Another way of thinking about it is when you divide by a smaller number, you get a larger number overall. So you want to take the denominator to be as small as possible. So we need to find the upper bound for the distance and the lower bound for the time. 24 is correct to the nearest integer, so therefore it's 24.5. Time is 4.32, correct to 3 sig figs, therefore it would be 4.315. Divide them, 4.315, and that gives you 5.68 meters per second, and that is correct to 3 significant figures. If I wanted to find the lower bound of the speed, I'd do the lower bound of the distance, the shortest distance, and the largest time. So I'd do 23.5 divided by 4.325. You're going to travel the shortest distance in the longest possible time. Put that in our calculator, and we get 5.43 meters per second. So we know that if I travel 24 meters, correct to the nearest integer, and in 4.32 seconds, then my speed is going to be somewhere between these two. The actual speed I'm going is dependent on exactly how far I go and exactly how long it takes me. We just have an approximation. These calculations are always the same. You always follow the same logic. Let's just try one last one. Let's say A is B squared plus C divided by D. B is going to be 5, C is going to be 1.1, and D will be 0.3. And these are all correct to one decimal place. If I want to find the largest bound of A, the upper bound of A, I'm going to take the largest bounds of the numerator and the smallest bounds of the denominator. So I'll do B plus C plus over D minus. Now these are correct to one decimal place, so 5 is actually 5.0. So I'll do 5.05 squared plus 1.15, and then the denominator needs to be smaller, so I'll do 0.25. Put that in my calculator and I get 106.61. So there we have it. That's how you go about finding the upper and lower bounds of calculations. Just remember, especially if you're dealing with division, you don't always take the upper bound of the values to find the final upper bound. You have to consider the question and consider whether taking a smaller number might actually give you a larger number all in all.